My presentation is it's just a case study of my own house, my own experience building a passive house using natural insulation. It's based in County Cavan. My house is just at the halfway down this hill. And this is a shot I took one morning walking the dog during COVID. So you can see it's it's in a rural part of Ireland, where you have lots of lakes and so on. To begin my project, in terms of the project, I began it in 2018 in Cavan. I do a bit of cycling, and I used to cycle over and back to the site to see how it was progressing at the start. And I engaged with an architect from the outset in my house, Niall Smith, architect from Kingscourt locally, a local architect. He set out some doodles of the site. I spoke to John Moorhead there, and I spoke to lots of architects I know around the country, with just ideas and feedback and their feelings and ideas and concepts. But Niall came up with this sketch of where the house is. The image you saw at the beginning, I took it from around here. So I'm looking due south, and I'm blessed to have two lakes to look out at. And I inherited this site from my father and the farm at home back about 20 years ago. So I was very lucky and fortunate to inherit that. So the basic concept was to have a house. Now, form factor wasn't the best on it. This is an open plan area. This is the sleeping quarters, utility and bedroom, and then a garage here. And this was a conceptual drawing, which the architect developed into a render. So it's basically a vernacular building in a contemporary style, in matching and keeping with a lot of the older buildings around the area, which would mainly be farmhouses and farm sheds in an agricultural area. You can see the house from a plan view here. This is the open plan area. This is the sleeping quarters and bedroom and office. And then at the garage here with shading provided by canopies. From the start of my project, a big area for me was to identify the airtightness layer, as you always would on any project. So defining the air barrier layer came naturally to me. And I defined it with the internal airtightness and vapor control board of a timber frame building, which I used in my project. So delineating that air barrier line is very important from the start, which is relatively straightforward downstairs, but upstairs it was somewhat more complex, because now I would have went with a very simple form, and but my wife was very keen to have a study above the kitchen in this vaulted open plan area, and I just didn't want it for selfish reasons of complexity and avoiding thermal bridges and airtight complications. But I knew my place, and I followed orders, and I went ahead with it, and we put in a room above there, which introduced challenges in ensuring airtightness was maintained at that point. So here we can see the build being dug out and getting ready for the foundation. And in the case of the foundation system, I used a passive raft foundation. It required much less digging out of the site, and it made a much more efficient install. And it also ensured I had even more thermal continuity, because I wanted to get a Pacify certified details, which weren't necessary. It's not necessary to use a passive raft. You could achieve it with a strip foundation, but this is what I used. And this is a brief video just showing the system being fitted by a local plumber. So that's the raft going in. So that just gives you an idea, and here we can see the detail. So the wall is a timber frame wall, internal plasterboard, a service cavity, which will be insulated with sheep wool or hemp. Then I have an airtight structural racking board, a timber frame of 225mm thick with blown wood fiber. Then on the outside, I have a Gutex wood fiber board, and then I have a breathable membrane and a vented cavity. On the outside, I have timber clad, I have cement board, and I have block work for stone and in some areas, so the variability in finish. And you can see here at the foundation junction where the passive raft and the external insulation interconnect to limit thermal bridging at these points that John referenced eloquently earlier on. This just gives you an idea of the benefits of externally insulating with the Gutex board. So I'm addressing repeating thermal bridges at structural timbers and cripple studs and so on, and any steel that had to be used in the building. I tried to minimize steel, but I did have to employ it in some areas. Here I am. It was actually a very hot summer. I went to the factory to see the panels being built, and it was built by a relatively local company called TimberTech Homes, who built timber frame, and this is Fergal O'Malley, the director of the company, and they delivered the timber frame to site and erected it in about a day and a half. So the whole frame went up. Detail and coordination on site was key, so making sure before the ground floor ceiling, or the ground floor ceiling went in, to make sure I had my lap for air tightness continuity between floors. And here I used the Solitex Plus, which is very airtight, but it can allow the timber to breathe as it laps around, and it's very resilient. It's got a 4-layer, 4-ply structure, so it won't tear. But oversight on site on the day of erection was key, so making sure the oversight was to a high standard. Myself and Roman just checked laps, made sure we fixed any damaged areas, which the team in the timber frame company would do anyway, but I'm just a bit pedantic when it comes to that sort of detail, so I wanted to be there too. So you can see the detailing, making sure laps of that seal were done, because once the building frame is erected, these details can't be addressed really effectively. And there you can see the completion of a corner junction with the Tescon Vanna tape and the lap sealed before the next floor level goes on. I mentioned this complex area for air tightness, which was this link from the landing into a room above the kitchen in the open plan area. So this required a lot of thought. You can see here, and we applied laps between the floors and also for the external cheek walls to make sure we had continuity in air tightness. So these sort of junctions, they're complex. But when complexity can't be avoided, I'd always recommend to embrace complexity and come up with a solution. And that's what we did here by having these laps in place. So you can see the glulam going in for the ridge beam on the open plan area. And here we've just a brief video showing the panels going into position. So off-site, we pre-drilled the structural boards, the airtight boards, so that later on in the building process, we could pump blown wood fiber into the panels. So it reduces labor on site and saves cost. You see the panels were very quick to erect. So they came open paneled. So the Gutex was fitted on site within a few days on the whole outside walls and also on the outside of the pitched roof. So we'll just move this on. So you can just see the detail and the work being carried out by the personnel on site there. So the outside of the roof, I used about, and outside of the walls, I used about 40 cubic meters of Gutex multi-tear. So it's 80 millimeters thick over the whole external envelope area. And on calculations I made, this equates to sequestering over 8,500 kilos of carbon. That's locked up in the insulation on the outside of the house before it's even used. So this is upfront carbon emissions. If I used XPS on the outside of my house, which I wouldn't use really anyway, but if I did, this would have a huge knock upfront carbon emission. But on the other hand, because I used the wood fiber, I've actually sequestered carbon within the material. This just gives a visual impression of that actual fact. This is another slide from our colleagues in the US in 475, where they compared using different insulation types and the embodied carbon to achieve a specific U value of 0.18. In this case, in my walls, I was achieving 0.11 in my roofing walls. But you can see here by using EPS, XPS, and mineral wool, there's upfront carbon emissions to achieve that U value, whereas with the wood fiber, we actually have sequestered carbon. So this is quite a significant improvement, not just in terms of reducing operational energy, but also the embodied carbon within the fabric. So this is the pitched roof you just saw a moment ago. On the outside of my slates, I have slate battens, counter battens, a breathable roofing underlay. Then I have the Gutex multi-term. In this case, it's 80 millimeters with full fill blown thermofiber, wood fiber. I have the internal air tightness layer. In this case, here it's Intello Plus. Then I have a batten here. It's a 3x2 batten I used on the pitched roof area to accommodate heat recovery ducts. And I have 75 millimeters of sheep wool. And then in this internal side, I have plasterboard. So you can see here on the outside of the roof, I have the breathable membrane. The one I used was Solitex Plus Connect, which has a pre-applied tape, which makes the sealing of horizontal laps for wind tightness much more efficient. So you're not having to tape our overlaps on site with an additional tape. You just remove or release paper and it gives a wind tight seal. And here we can see the roof of the cold roof area on the sleeping area block and the utility rooms counterbattened. The detail here was to fulfill my joists in this zone with about 450 millimeters of blown wood fiber throughout, the counterbattened roof, and then you can see the continuity achieved with the Gutex meeting up to the thermofiber in the roof. This is my brother-in-law. I spent about 5 weekends putting on slates with him, yeah, it was great to do it. We put on the slates throughout the roof and took great care of the eaves to make sure the wind tight detailing was correct. But also we pre-applied grommets, airtight grommets on the outside of the Solitex in positions where in the future I may apply additional ducting on the outside, such as for exhausts, for heat recovery, or soil vent pipes in the future if they were needed. I strategically positioned these EPDM gaskets. So this is the roof pretty much complete. You can see the exhaust for the heat recovery, with the actual cowl has to go on that yet. So the house is weather tight. These are two of my daughters. My son isn't in the image here because he'd only cause trouble. But they're in the house very excited that the windows went in. I used timber alu-clad windows. And then I could get to work just to prove I'm not just a pen pusher. I got to work fitting the Intello on the ceiling of my of the upstairs. But key throughout the process was communication. So making sure plumbers, electricians, and glaziers, and every trade basically that interacts with the external envelope is aware of where the air barrier is and their role and the importance of communication of any damage to it, that it can be remediated. So work on the air tightness was done over about a week and a half. We can see the detailing needed to make sure straps were sealed, the Intello was sealed to the airtight board on the external walls. You can see the vaulted roof area, which we completed over about a day and a half, and then the external walls as well. And then another key step was to make sure we accommodated services. So we applied the service batten on all external walls and on the ceiling to ensure that later on cables, pipes, and so on can be accommodated. So we can see that in this area here where cables are easily able to run through the service zone without compromising the air tightness. So again, we can see the service battens here and the details used to seal around complex junctions and making sure windows were sealed adequately. For the heat recovery unit, we can see all the supplies were sealed with these grommets. Tapes could be used, but a grommet gives much greater flexibility in terms of adjusting the pipe later on. And also it's much quicker to apply because the biggest cost in terms of air tightness is time. And so anything that saves time is generally saving cost. And a key area in the ceiling and the cold roof was the air adder catch to make sure it was sealed airtightly. And here I used a certified airtight and pre-insulated adder catch. So we can see it here. So there's a seal on the door as well as for the surrounding frame back to the air barrier layer. And then for complex junctions like ducts or pipes coming up through the foundation, if there was areas which are bunched together, this is where the airtight paint was useful. This is an example of one. I used to seal around bunched up pipes or ducts coming up through the screed in some areas. I did have training days, tried to build process. I invited builders, architects, local authorities to come along. And before the plasterboard went up and in April 2019, I had an open day where we had about 50 people came, and I invited suppliers of the ventilation, the heating system, the windows, and the architect all to give presentations about NZEB and about Passive House as well. The heat recovery unit I used was a Brink Excellent Renovant unit. I took it apart sometime last year. My wife was wondering would I get it back together again, but that's what engineers tend to do. I did manage to get it back together. It's working very efficiently. And that's applying all the fresh air to the house. The pollen filter G7 here, and I have a G3 one there in the outlet. But you can see, even though I live in a rural part of Ireland with plenty of fresh air, the filter was still quite dirty after just 2 or 3 months on the pollen filter. You can see the need to make sure we maintain these units. So these units, as they're very desirable and very effective, it's critical that they're maintained, that filters are changed regularly, depending on the environment where your building is located, to make sure it doesn't impact indoor air quality. But I've 2 of my kids, or my 3 children, are asthmatic, and since we moved into the house, they haven't needed inhalers, and their coughs or anything like that is pretty much disappeared since we moved from our previous house. So that's really complementary to the comfort and air quality within the house. The heating system I used was an air-to-water heat pump. I think it's a 8 kilowatt Daikin Alterma heat pump, and that's supplying hot water and space heating. Challenges, well, there was a few air tightness challenges. Remember this fella earlier on in the presentation? Well, we forgot one thing here, and that was to put our Solitex lap beneath this. The Solitex lap went on, but it didn't go on until after, which meant I had this tricky junction to seal afterwards. That could be overcome, just meant there was a bit more complexity at that junction. So even with people that are experienced with air tightness, of course, of passive house, there's always room for an oversight. And this was a bit of butchering by one of the tradespeople I went through everything. We had meetings, but still they managed to damage not only the top rail of an internal stud, which luckily isn't load bearing, but also the air barrier layer to support for supplying the heat recovery ducting. But that again could be remediated. The electricians overall are very good. There's just some spots like this cable coming through a top rail and a stud penetrating the airtight lap, which could be sealed from above quite easily. But it just shows you do need a degree of care and constant oversight on site. And sometimes grommets just aren't able to accommodate some services, and that's where these butyl tapes, such as this Exto Seal Mag-Off tape, was really useful to seal around the ventilation ducting coming down a wall horizontally against the wall, and allowed me to get an airtight seal at that point. Yeah, and accommodating the ventilation system, I think that's a critical point. It's very important for installers and for occupiers to make long-term comfort levels. So the people fitting this gear, it's very important that they're trained, and this is where training with organizations like the WWETB and other bodies is going to be so crucial in the future to make sure these systems work efficiently. So coming closely to my end, once the air tightness work was done, I could start pumping the wood fiber into all my walls, attic and roof. I got about 250 bags of Gutex thermofiber, which equates to about 1,650 kilos of carbon locked up within them bags. So by getting this insulation, I'm sequestering carbon and putting it into my walls instead of getting materials which have emitted carbon before they get to site. So this is the upfront carbon emissions being accounted for. And yeah, we pumped it into the attic and all the areas. The process is to cut the bag, open it, put it into the mixing machine, and then it goes through a pipe under air pressure and it's pumped into the cavity. So here we are injecting it into our stud. I had a training day with some installers at the house. We're fitting the thermofiber into a wall here. I'm trying to do it there, and it's just been, that's filling a 220mm stud there. And here is Roman, one of the airtight installers, demonstrating it post installation. And you can see here, he cuts the middle of the stud, just removes the Intello, just to show how it compacts and the fibers bind to each other to give a very full fill within the cavity without any risk of any settlement. So then the blower door test, there was a preliminary blower door test which came in at about 0.38 air changes per hour at 50 Pascal. We found some leaks during the prelim test. So having these preliminary tests are key for identifying leaks and being able to remediate them. And once we're happy with the preliminary test, we insulated the service cavity. So myself and my children and my wife, we applied sheep wool insulation in the service cavity over a few days, and we insulated all the service cavities throughout the building with the sheep wool. So this is the thermofleece, just friction fitted between the battens. So in terms of the house, how did it perform how does it perform if we were to look at it? The U values overall are about 0.11 for the walls, roof. The floor is about 0.1 U value. The house achieved a 0.4 air change per hour at 50 Pascal N50 value. And if we were, my colleague Joe Fitzgerald carried out an exercise using the Deep software to examine the running costs for the house, depending on the air tightness levels achieved based on 2019 Irish weather data, with elemental U values of 8.1, and based on electrical cost consumptions referenced within SAI. And if we were to notionally say the house achieved a backstop value of 5, leaving aside the heat recovered by the heat recovery unit and other elements, the running cost for space heating would have been €1,739 per year. This is even with a U value of 0.1 elementally. So we can see without air tightness, the U value just isn't going to deliver, and overall performance will be compromised. So by achieving the air tightness levels I attained of about 0.4, the notional running cost for space heating was down at about €328 per year. So we can see air tightness is really the key link within the chain of ensuring fabric performance is actually delivered without a performance gap. So in terms of the preliminary cert, which I hope to get the final cert very soon, my heating demand is at 11 kilowatt hours per square meter per year, and my heating load is at 10. So I'm very happy with that. My primary energy demand is at 95 kilowatt hours per square meter per year, and my N50 came in at 0.4. So I was very happy with that. In the house, I haven't put PV in yet, but I planned for it and I will soon. I just threw the kitchen sink at the fabric, and with the hope in the next couple of years to put some PV in to bring in to reduce the primary energy demand. We can see here my BER came in at A2, just 3 kilowatts short of the A1. But with the solar PV installed, even a small array will easily bring me up to A1. But that's the BER at the end of the process. And an exercise I'm going to conduct over the next year is I'm going to work with some people to develop a passive house ribbon calculation to assess the embodied CO2 in the building. As you can see here, this is just a sample pH ribbon slide I borrowed from Tim Martell with the ACB in the UK are running a training on this. But you can contact Tim at tim@phribbon.co.uk for more information. And there's also information online. It's a fascinating tool that simplifies the process of passive house planning package use, and also allows you to assess the environmental impact of the materials used in the building. So this is the house pretty much as it is. That's Lola, my dog. So I got the ground seeded last summer and a little bit of shape taken to it. Still a lot of work to do outside, but it's pretty much to what the architect designed. So that's basically it. Conclusions I'd have would be air tightness really starts at the conceptual stage, start early, reduce complexity, and buildings can vary in form, but there is always room for simplification, and embrace complexity where there's no other option, and come up with solutions prior to project commencement. At the drawing stage, plan the air barrier layer, and it'll highlight penetrations and critical junctions. And engagement, this is critical throughout the process. So air tightness and controlled ventilation is the key link to healthy low energy buildings without the performance gap. And it's the common denominator which links all trades together for better build quality. And more airtight building is generally better built. So clever design and a fabric first approach really reduces operational energy. So by building clever, it allows specifiers to optimize material usage and design with low carbon materials. EPDs, this provides a complete and transparent information to reduce greenwashing. And EPDs will lead to greater transparency and will aid as a key decision maker to make informed decisions with lower environmental impact. The development of EPDs, this will encourage manufacturers to develop more sustainable supply chains, and material choices have significant impact on upfront emissions. Installation choices greatly affect carbon footprint of a building in terms of embodied carbon and operational carbon emissions. And insulation can either be a significant contributor to the embodied carbon footprint of the building or carbon sink, depending on choice. Over 10,000 kilos of carbon were sequestered within the wood fiber used in my house. So materials such as wood, straw, clay, and other materials, these naturally sequester and store carbon. And finally, early decisions at the design stage are key to decarbonise buildings. By reusing buildings rather than demolishing buildings, getting your site selection right and location, optimizing building form and size, looking at your structure and engineering in or engineering out complex loadings with more sustainable materials, optimize the envelope and be selective about the materials you use. And Denmark, finally, it sets out a phased embodied carbon targets for buildings recently. And this was in Pacifies Plus recently, where Denmark is set to introduce embodied carbon targets in the country's building regs. And I think that's absolutely crucial now going forward. And we're going to see that more and more in the months and years ahead. If you wanted more information on my house and many other projects, there is this recent publication, Understanding Pacifies book by Emma Walshaw. It's available on our website. Both the detailed thermal calculations as well as the actual drawings are all available there. And for further reading, I have information there, which I'm happy to share. So thanks for your time today. As I said, after today, we do have a service of providing U-value calculations, building project guidance and training as well. After today, if you have more information, please feel free to contact us. I'd like to sincerely thank all our speakers. They're just put in so much work to their presentations. I was just really, really impressed by everyone. And I'm sure I speak for all our guests when I say thank you sincerely very much to every one of you. Your insight and your projects and also the training and other information you've delivered is inspiring. And hopefully it will inspire our delegates to move forward and not just look at reducing operational energy, but also looking at and being more aware and conscious of the future carbon emissions or upfront carbon emissions materials can have. So without further ado, I'd like to bring this event to a close, and hopefully we'll see you at future events. Keep an eye on our website for future events and training. And thank you very much. Okay, have a good afternoon. Bye-bye.